Now let's apply Wien's law, the only actual equation from D2, a big subunit. So Wien's law is presented like this: lambda max T equals the Wien's law constant, 2.9 times 10 to the minus 3. The MK is confusing, looks like millikelvin, it's not, it's meters Kelvin. So, you remember that stars, of course, are good approximations to a black body. So if we plot their wavelengths against intensity, we get something like this. So it emits and absorbs every possible wavelength, but not evenly for all of them. There is a peak wavelength. So it's very useful in astronomy, like a gift. We can measure, by spectroscopy, the peak wavelength. Then we can work out the surface temperature. So let's give that a go now. Suppose we observed a star and we found that lambda max, we found that it's 500 nanometers. What's its surface temperature? So temperature should be the Wien's law constant, 2 equals there, over 500, but be careful, of course, that's nanometers. So you would cancel that, cancel a couple of those. So 2.9 over 5 times 10 to the negative 4, which is 5,800 Kelvin, the surface temperature of a black body of that peak wavelength, which is pretty much our sun, and that is the surface temperature of our sun.